In this set of videos, we're going to learn to solve a system of equations by using an augmented matrix. What an augmented matrix is it's a matrix that has the coefficients and it has the solutions for a set of linear system of equations. So you may remember doing this in algebra, but without a matrix, and you had to do it by hand, like doing a 2 by 2 system, something that has just x and y, two equations and two variables. This is not too hard. You just do it by substitution or elimination. But whenever you throw in a third variable, an x, y, and z, and have three equations, then it gets a little tougher. Sometimes one problem took a single piece of paper, a whole piece of paper. So we're going to take our numbers and we're going to tuck them into an augmented matrix and then do these elementary row operations until we get to a point where we just have the answer. And we can actually do this very, very quickly on a calculator, but I want you to understand what your calculator is doing whenever you ask it to put it into reduced row echelon form and solve the system of equations for you. So we'll start off by looking at this simple system of equations. It's a system of equations got x, y, and z, so it's a 3 by 3 system. But this one's really easy to solve because you already have z. Z is equal to 3. To find y, I just take the z and plug it in for z in the second equation. I get y plus 2 times 3 is 6 equals 5. Subtract it over, y equals -1. And then finally, to get my x, I take both of those y and z and put it into the top equation. X minus 2 times -1, that's actually plus 2. Plus 2 times 3 is 6 equals 9. That's a total of 8. Subtracted over x equals 1. So you write your final answer as an ordered triple: 1, -1, and 3. You can see how simple that was to solve. So the set of equations that we just looked at, it's equivalent to this larger looking system over here, one over on the left. And what that means is not that the equations are exactly the same. You can see that the top equation looks like this top of equations, but the other one does not. What an equivalent means is that if you were to solve the one on the left, you'd get an answer. You'd solve the one on the right, it would get the exact same answer. And really that's all we care about, is that final answer. So we would much rather solve this one on the right than solve the one on the left. The question is just how do we get it into this form so it makes it so easy to solve. So the system of equations, as I already mentioned, says it's in triangular form. So it's called triangular form because it just makes like a little triangle over here on the left-hand side. The equations are in decreasing order of number of variables. So I've got 3 variables in the top, and then 2, and then 1. This is also called echelon form. And then we also like to have the leading coefficients of 1 in each of the equations. So the question is, how do we get it into this nice handy triangular form? So the answer comes from this mathematician Gauss, who did lots and lots of stuff in mathematics, and this is just one of them. So it's sometimes called Gaussian elimination, named after him, or just simply elementary row operations, and there's 3 of them. So let's take a look. So the first one is you can take any 2 equations in your system of equations and you can flip the order. Like I can exchange the first one and the second one and it doesn't change the answer. The second one, I can multiply whatever equation I want by some constant. I can multiply it by half, by a third, whatever I want, as long as it's not 0, because multiplying by 0 makes everything 0 and that would just be dumb. And then the last one, I can take a multiple of one equation and add it to a multiple of the other equation. And the interesting part about this is that we replace that previous equation with our new equation. I don't just get a 4th equation, I just simply replace my old one with the new one. So we'll see how all of this works in the next video.